Okay, so this will be 1.1, solving compound inequalities. You solved compound inequalities in Algebra 1, whether you remember that or not. The new part of this lesson is how to write that particular inequality in set builder and interval notation. Okay, so that part is new. What we're going to look at are bounded and unbounded intervals on the number line. So for bounded, if you have two numbers, A and B, where A is less than B, then those are the endpoints of 4 different bounded intervals on the real number line. So if you have two set boundaries like this, that is a bounded interval, okay? It's kind of like a segment from geometry, if you remember that, okay? And unbounded is where you've got the same A and B real numbers, but you only have one boundary, and it goes on to infinity. So kind of like a ray in geometry, okay? So we're going to look at how to express bounded and unbounded intervals in interval notation and set builder notation, okay? Your interval notation is the most popular that you will use from this point forward, especially when you do domain and range and stuff like that. We'll do increasing, decreasing portions of functions, and you'll be using interval notation for that, okay? That'll be later on in the year, but this we will revisit, okay? Set builder notation you'll really only do now for this lesson, but all that is expressing it as your compound inequality. So this key thing right here is indicating the two most important parts of your interval notation. A bracket indicates that it's included in the interval. So if you think back to when you graphed inequalities on a number line, you always had an open or a closed circle, right? So a bracket is when you have a closed circle on the number line. Okay, so that means it is equal to, that is included in the interval. Now, if you had an open circle, that would typically mean that it's not equal to, and that is represented with parentheses. Okay, so it would not be included in the interval. All right, so if you need to write it to the side, an open circle is usually when you have less than or greater than. Okay, those are your inequality symbols, and those are represented by parentheses. A closed circle is less than or equal to, greater than or equal to, so because it's equal to, it's included, and those are represented by brackets. Okay? So, if I'm looking at this first number line, okay, I've got my boundaries A and B, and they both have open circles. So because they're open, it's not included in the interval, we write them with parentheses, okay? For an interval notation, you literally only write that endpoint with a comma separating it, and your notation bracket or parentheses, okay? It's very simple. Now, your set builder notation, set builder will always have this template, and your inequality goes right there. So what does that mean? This is really reading x is a member of the real numbers such that blah, blah, blah. Okay, so this would read x is a member of the real numbers such that x is between a and b. Okay, when it's written like this, that's all it means is x is between those two. Okay, if you cover this up and read it backwards, it's telling you x is greater than a and x is less than b. Okay, so that goes to your and compound inequalities. So your and really means it's between, like I was reading. This comes from Algebra 1. Okay, anytime you had to write an and compound inequality, it looked like a number is less than x, less than a number. Okay, and that's telling you what I just read. X is greater than that smaller number, and x is less than the bigger number. Okay, so your left number in that setup should always be the smaller number. It should always be your left boundary. Okay, the right number in that setup is the right boundary, and that should be your greater number. Okay, your inequality symbols will always be less than. It could be equal to, but it's always going to be less than. Okay, because of the way that I just read that to y'all. Okay, y'all good with that? Alright, so what this doesn't show is what it looks like whenever it's an or inequality. and or has a gap. Okay, we're going to look at that in a few examples, but or has a gap. So if and looks like this, or is going in opposite directions and will look like that with a gap in between. It's either the left or it's the right. Okay? So for that, when you're writing that inequality, it will look like x is less than a number or x is greater than that right number. Okay? Again, left number, left boundary, right number, right boundary, left number smaller, right number bigger. Okay? Y'all good with that? That's just a brief refresher and a template of what your and or should look like. Okay? Because we use that for set builder notation. Alright? So these first four all look the same. The only thing that's changing is one is equal to one, and these are included. Okay? So if it's a closed circle, again, that's a bracket. Open circle is parentheses. Okay? Now, these are our unbounded intervals. Okay? This is where you only have one endpoint, and it goes on to infinity. Okay? So here, my A is my left boundary, and it's going on to the right. So if it's going on to the right, that's going to positive infinity. Okay? So that's where this interval notation is coming from. You're starting at A, and you're going to positive infinity. Okay? Here, I have a right endpoint at B, so it's really going to negative infinity. So my interval notation will be negative infinity to B, and it stops at B. Okay? It doesn't include B, so B has parentheses, but that's really what you're reading. Okay? So if you have positive or negative infinity, those will always be parentheses. Y'all good so far? So then, if I have something where I don't have any boundaries at all, I have no endpoints, no boundaries, that's going to be my all real numbers. Okay? Y'all should be familiar with that phrase. Your interval notation for all real numbers is negative infinity to positive infinity. Okay? Now, for set builder, we don't do an or. All right? What we do is we set up our notation for set builder, and we write this X, fancy E, that has a name that I just call it fancy E, but we're going to have XER. So that just tells you that X is all real numbers. Okay, y'all good with that? So, if we're looking, all this does is reiterate what I said up here. Your and is between, and you have an overlapping, okay? Or are two separate directions, and there's a gap there, okay? So if I'm looking at examples 1 through 3, I give you the number line, and you have to write it in set builder and interval. So my set builder, I'm going to go ahead, set it up, okay? Looking at this and knowing the template that I just wrote over to the side, is that an and or an or inequality? It's an and. I've got overlapping. I'm shaded between my two endpoints. Okay? So that means my X is between what two numbers? 40 and 70. Okay? So if you know it's an and, if you want to set up that middle template, this is never going to change, okay? So when I teach it in Algebra 1, I always say do this first, and then you put your endpoints, okay? So I know it's an and, bless you. I know it should look like this. I bring down my left boundary. I bring down my right boundary, and I look which one should be equal to. All right? 40 has an open circle, should not be equal to. 70 has a closed circle, so that is equal to. So this is reading that X is greater than 40 and X is less than or equal to 70. Y'all good with that? Okay. So for my interval notation, I have my two endpoints, 40 and 70. I need to know which one's parentheses and which one's a bracket. If 40 is an open circle, which one is it going to be? Parentheses. 70 has a closed circle, so that should be a bracket. Okay, do we have questions on that? All right. So then if I'm looking at example 2, I only have one endpoint. Okay, so is that going to be bounded or unbounded? Unbounded. Okay, so when I set my set builder up, I'm going to have a simple inequality like these. Okay, if I were just looking at this, I know my endpoint is -8. Is my graph showing that it's less than or greater than -8? Less than, and it's also equal to. So all I have to write is x is less than or equal to -8. Okay, when you're doing a simple inequality for an unbounded interval, make sure it's always x, then your inequality, then the endpoint. Okay? Now my interval, is this a right or a left endpoint? If I'm looking at my graph going from left to right. This would be a right endpoint because it's going left to -infinity, right? So my interval would go from -infinity to -8. -8 is a closed circle, so I'm going to have a bracket. Bless you. All right, now if I look at example 3, what type of inequality is that? And or? Or. I've got a gap in the middle, so that's an or. All right, so whenever I set up my set builder, I express the left, put or in the middle, then express the right. Okay, so if I'm just looking at this left portion of my number line, what inequality will represent this? X is what? What's my boundary? 5. So x is what for 5? X is less than 5. Good job. Put your or. Now my next boundary is 7. So x is going to be what? Yep, x is greater than 7. Okay? Now, I have 2 portions of my graph on the number line, right? So that means when I do interval notation, I should have 2 intervals, and they're separate, okay? So we're going to do the left interval, so that goes from -infinity to 5. Will 5 have parentheses or a bracket? Parentheses. Now, instead of writing the word or, we put a U, kind of like for union. Okay, so for interval notation, when you have an or compound inequality, you're going to put that U there to separate it. All right, then I start back at 7. 7 has parentheses also, and 7 goes towards positive infinity, which also has parentheses. You're good with that? Any questions? So now I give you set builder, and we got to write it in interval, and we got to graph it on the number line. I don't care which one you do first. If you are more visual and you need to put it on the number line for you to see what the interval is, that's fine. Or if you are good and can just drop it into interval notation, that's fine too. Okay, I'm going to graph it for y'all just so you can see it, and then we'll do interval. Okay, so here I've got the inequality -1 is less than or equal to x, less than or equal to 5. Okay, so my 2 boundaries are at -1 and 5. Okay, -1, open or closed circle? Closed, because it's equal to. What about 5? Closed, because that's equal to. All right, so when you're doing your number line, you just have to do your 2 endpoints. You don't have to do every dash in between, okay? Now, where am I going to shade? If x is in the middle of that, for my inequality, I'm going to shade in the middle. So then I get to do my interval notation. Okay, so my endpoints are -1 and 5. -1, will that be parentheses or bracket? Bracket. And 5, bracket, because it's included. Okay? All right, x is less than -3 or x is greater than 2. My two boundaries are -3 and 2. What type of circles am I going to have for both of these? Open. Now it's an or, so I should expect to see a gap, right? They are going in opposite directions. X is less than -3 goes to the left. X is greater than 2 goes to the right. So when I write that interval notation, I should have two separate intervals separated with my union, okay? So I'm going from -infinity to -3. That's going to have a parentheses. Put your u. Then I'm going to start back at 2 and go to positive infinity. Okay, now for example 3, it tells me x cannot equal 2. So what do you think that looks like? Just an open circle at 2. But is that it? Should I have shading? So in words, what do you think x cannot equal 2 mean? Can't be 2. Can it be anything else? It can be everything else, right? It can be everything but 2. So that means it can be all the numbers less than 2, and it can be all the numbers greater than 2, but it cannot be 2. Okay? So in terms of and versus or, what do you think that's going to be? Okay, so am I going to have something like this when I write my interval? Or am I going to have something like this when I write my interval? Because it can be less than 2 or it can be greater than 2, but it cannot be 2. Okay, so when we write this interval, we're going to go from -infinity to 2. Bless you. Put your u, and we're going to start right back at 2 to positive infinity. Are good with that? Okay. All right, now what if I give you interval and you have to graph it still, and then now we're going to do set builder. Okay? So if I have -8 to -2, I know that's what I can put on my number line. -8 has parentheses, so is that going to be an open or closed circle? Open. -2 is going to have what type of circle? Closed. All right, where is it going to be shaded? In between. Because this is telling me I'm going from -8 to -2. So I'm going to be shading in between. Okay? When it's separated, that's when you have separate. If it's all in one, you should only have one shaded area. Okay? So my set builder notation should look like an and inequality. So I know my x is in the middle. I know my inequality symbols go on the right. My left boundary is -8. Not on the right, around it, sorry. My left boundary is -8. My right boundary is -2. Is that my final answer? No, why not? It's equal to. -2 has a closed circle, so it should be equal to in my set builder notation. Okay, y'all try to do number 2, and then we'll check it. I can plot my -2 and 20 on my number line. What should -2 have? And 20? Shaded in the middle. So what do I put here? Very good. Are good with that? All right, now for 3, negative infinity to -2, or 5 to infinity. Okay, so my 2 boundaries are going to be my -2 and 5. -2 will have what type of circle? And 5 will have closed also. Now, it's split into 2 different intervals. So I should have 2 separate shaded regions here. Okay, so it should be gone to the left of -2 and to the right of 5. So then my set builder notation, what is going to express this left portion of the graph? X is what? Less than or equal to -2, or X is what? Greater than or equal to 5. If it's going to the left, it's less than. Left, less. Okay? Y'all good so far? Do we have any questions? Alright, so now we're going to bump it up. We're going to solve. Then we're going to graph and do set builder and intervals. So we're combining everything together. Okay? So the way that you solve an OR compound inequality is different from the way that you solve an AND. Okay? Now, you solve inequalities just like you would an equation, except for this one rule, that if you multiply or divide by a negative, you have to flip that inequality symbol. Okay? Other than that, everything is straightforward. Okay? So this first example, we've got 3x minus 1 is greater than -2, or -2x plus 5 is greater than or equal to 11. Okay? It's an OR. It's one or the other. So we are going to solve them separately. We're going to solve the left, get it down to where it needs to be, and then solve the right. Alright, so if I have 3x minus 1, I want to solve for x. What am I going to get rid of? Okay, how am I going to do that? When I do the left, I have to do the right. So 3x is now greater than -1. Now what do I do? How do I solve for x here? X is greater than -1/3. Now, even though this -1 was a negative, don't have to flip my inequality because I'm not dividing by a negative 3. I divided by a positive, so I don't have to flip that. Okay? Now this right one, negative 2x plus 5 is greater than or equal to 11. What am I doing here? Minus 5. So negative 2x is greater than or equal to 6. Here I got to divide by negative 2. X, I divided by a negative, so I flip that inequality. Okay? Now, this was an OR. What do I know about my OR and what it should look like? OR is typically x is less than a number or x is greater than a number, right? Well, what's happening here? If I were to just tack my OR on in the middle, what's wrong with that? All right, so they're in the wrong order for 2 reasons. I know that because I know what my signs should look like. I also know that because this is smaller. Okay, so really what I'm having is x is less than or equal to negative 3, or x is greater than negative 1/3. So you have to be careful when you're doing these inequalities. You have to check yourself, are my inequality symbols going the right way? Is my left number my smaller number? Okay, you have to double check yourself. Okay, now this is what the compound inequality looks like, but I didn't ask to just get that. Okay, I asked for a graph, set builder, and interval. What I'm going to do, this is what goes in my set builder. I'm just going to tack on my template instead of rewriting it. Okay, so once you get it down to the proper answer, your final answer, tack on your set builder notation around that. All right, now if I were to graph that, I would have negative 3 with a closed circle going to the left, and I'd have negative 1/3 with an open circle going to the right. Now what's going to be my interval notation? This left portion, what is that interval? It's shaded towards where? Does it? Negative infinity. And it stops at negative 3 with a bracket. And then parentheses, negative 1/3, and that goes to positive infinity. Okay. Now here, I've got 4 is less than 2/3 x minus 8, less than or equal to 8. This is an and. If I don't have the word or, that means it's an and. Okay? In and, you're going to solve all at the same time. Okay? It is all together, so we're going to solve it all at the same time. Okay? Technically, you have 3 parts to this. You've got left, middle, right. Okay? When I teach this in Algebra 1, I always say, you've got 3 letters in and, you better do that operation 3 times. Left, middle, and right. Okay? If I'm looking at it, my x is in the middle, I'm working from the middle out. Okay? If I want to get x by itself, what am I getting rid of? The negative 8. So I'm going to add 8 to the middle, left, and right. So 4 plus 8 is 12, less than 2/3 x, less than or equal to 16. All right, now if that were just a 2x, I would be dividing everything by 2. But this is a 2/3, so what do I do with the fraction? multiply it by the reciprocal. Okay? So you're going to multiply it by the flip of that fraction. So you're going to multiply everything by 3/2. Do not divide by a fraction, or you will lose credit. Y'all understand that? Y'all go back to when you learned fractions and y'all did, if they still teach it that way, flip, change, keep, flip, change, keep, change, flip, something like that. It's been a long time for me. But you're multiplying by that reciprocal, okay? So, if you are not good with fractions, your calculator, I have an issue with the glare, but your calculator has this button right here. Under mode, it gives you a fraction. So, if you're using a different calculator, make sure you know how to do it on this calculator because that's what you have for a quiz and a test. Okay. All right, so I can type my 3/2 and then multiply that by my 12. It will give me 18. All right, so your calculator can do your fraction for you if you're not good with it. So that's going to give me 18 is less than x, less than or equal to, what's 16 times 3/2? 24. Okay, so is that in the proper order? Is my smaller number on the left? Are my inequality symbols making sense? Yeah, so I'm going to put my set builder notation around it. Now I know it's between 18 and 24, so I can just do my interval notation. 18 does not have an equal to on it, so that's a parentheses. 24 does, so that's a bracket. So whenever I do my number line, 18 has an open circle, 24 has a closed circle, it's shaded in the middle. What questions do we have for that? Y'all are good? All right, now here, it's an or. What do I do first? I know I got to solve the left one. What do I do on the left one? What do I do first? Distribute. I got parentheses. I've got to distribute that 3 to those numbers inside the parentheses. So 3 times 5 is going to give me 15x, plus 3 times 2 is going to give me 6. Carry down the minus 8, less than or equal to 43. All right, now what do I do? I need to combine like terms. That right there is 6 minus 8. I need to simplify that. Okay, so 15x, 6 minus 8 is negative 2, less than or equal to 43. Going to add 2. 15x is less than or equal to 45. Divide by 15. X is less than or equal to 3. All right, on the right side, 4 minus x is less than or equal to 10. What am I getting rid of first? The 4. Is 4 positive or negative? Positive. This 4 is positive. My x is what's negative, so you got to be careful whenever it's like that. All right, it's positive. I actually need to subtract it. So I have a negative x is less than or equal to 6. What am I going to do here? Divide by negative 1. X is greater than or equal to negative 6. Now this is an or. If all I'm looking at are my inequality symbols, it looks like it would be set up right. But what do I know about negative 6 and 3? This is smaller. So it's really telling me x is greater than or equal to -6 or x is less than or equal to 3. Well, if I were to graph that, I would have a closed circle at -6 going to the right. I'd have a closed circle at 3 going to the left. What happens? It's kinda, so you see it overlapping. All right, this is one of your special cases. All right, it hits every single, if I had dashes on this number line, it would hit every single number on this number line, right? So what special case would that be? All real numbers. Okay, so that is my negative infinity to positive infinity. So as set builder, that's when we have our XER. So that's why it's important to really look at which is your smaller number and where your inequality symbols pointing and what do they represent. Okay, always check yourself when you're done with a problem like that. Okay, so for the last example, we've got 14 is less than or equal to 2x plus 4, less than or equal to 6. I want to solve for 2x, so what am I going to do? Subtract 4. All right. If you are someone who needs the reminder, put an and next to that, so that's not what you do on a quiz or a test. A lot of people just do it to the right or do it to the left and forget the other one. All right, make sure that you're doing it to all three. All right, 14 minus 4 leaves me with 10, less than or equal to 2x, less than or equal to 2. Divide by 2. That leaves me with 5 is less than or equal to x, less than or equal to 1. Is that correct? If I were to box that in, would I get full credit? No. What's wrong with that? Which one really should be going on the left? The 1. So if I were to flip this, this 1 needs to go on the left. All right? That doesn't mean I just automatically flip 1 and 5 and don't adjust my inequalities, because this is telling me x is less than or equal to 1. X is greater than or equal to 5. So if my smaller number is on the right, I flip the entire thing. So I'm going to have 1 is now going to be greater than or equal to x, greater than or equal to 5. Because that's what this reads. This reads x is less than or equal to 1. X is less than or equal to 1. X is greater than or equal to 5. X is greater than or equal to 5. All right, so now that I put my numbers in the correct order, least to greatest, now what's wrong? My signs are wrong. So if I were to look at what this graph means, this graph means I've got x is less than or equal to 1. That's what this is telling me. So that would go this way. This is telling me x is greater than or equal to 5. What type of inequality does that represent? An or, but I started with an and. An and should be overlapping in the middle, right? Is anything in the middle of 1 and 5? No, that's no solution. So if you don't know what you're looking at, if you don't know what type of inequality you're working on, you don't know what the graph looks like, you can't always self-check on whether this is a special case or not. Okay? Y'all understand those two special cases? Yeah, we have any questions? All right, so this is what's going to be your first quiz. It will be over that. Now, I want to make a note before y'all do your worksheet, because there's going to be a situation on your worksheet. What if that would have been 5 is greater than or equal to x, greater than or equal to 1? I recognize my 1 needs to go on the left. When I flip all of that, it puts it in the proper order. Now I would have had a 1 go into a 5. Okay? So just pay attention that when you're working on your worksheet or a quiz or a test, when you double check that smaller goes on the left, make sure those inequalities make sense too. And that doesn't give you, this does not give you a special case. So you have to be able to read that inequality. Okay? Oh, good. All right, so your quiz is going to be next class. This will be due next class. I have the answer key in the Google Slides in Google Classroom. You can either get on your laptop and do that, or you can come up here and you can check your work with the key. Okay? But if you get done before the class is over, you can turn it into y'all's tray second period. When you turn in your paper, you can get your phone. Okay?